Okay, then let's start. So thank you very much for coming. It's Sunday early. So the name of my talk is Adopting Java for the Serverless World. I was asked to give this in English, but I'm a German-speaking one. So I will also take the perspective from AWS cloud provider. It's the only one where I have knowledge. And first of all, I would like to ask you, who is from you a Java developer? Oh, okay. Only several. Interesting. Who has experience with the cloud providers itself? Only several of you. AWS? Okay, just it's become even less people. Okay, then I will try to explain things because this is mainly talk how to adopt Java on AWS. Mainly the same techniques can be applied to Azure and other stuff, but it's not the talk about why serverless and what are the advantages of this. I gave similar talk, I think, 2 years ago at FrOSCon. So my name is Vadim. I'm Ukrainian native, so not very easy times also for me or for my country especially. And I have two passions, Java and serverless on AWS. I'm one of the co-organizers of Java user group Bond, so I live here around the corner. And so I spent probably the first 20 years of my career programming Java or dealing with Java starting in '98, and then especially due to all migration efforts at our company, we gained a lot of AWS knowledge itself. So you can get in touch with me. So I have very unique surnames, so you can find me everywhere. Very active on Twitter, tweeting about serverless, AWS, Java, so that's all this stuff. So I'm working for the company called IP Labs in Bonn. Probably you know us or used our software. We are in the business to business, so we are kind of hidden. But what we are providing is the software for designing and editing of the photo products, like photo book of the year, calendars, prints, posters, so everywhere where you can print the photo, especially. So if you use PostX, Excel, and so on, then we are kind of the software provider behind it. As I told you, we just had a lot of Java backend, but we have closed all the data centers and migrated to AWS within last, I would say, 4 years. So a lot of experience with the classic infrastructure, with virtual infrastructure, also serverless. We're kind of very mixed. Okay, I will try to embrace more because the knowledge is a bit spread here, so I will also go over several basics. So let's start with the Java popularity as the programming language and what you will see here over the years. So Java is quite popular. Depending on what source you will see, you will take, then it's probably something between place 1 and 3. Depending on how it's calculated, sometimes at GitHub repositories, sometimes as job postings or Stack Overflow questions. So depending on how this metrics works, it may be something like this. And even for the last year, or for the last this year, nothing changes. It's just there above. So we will look into the AWS and serverless stuff. It's not released for this year, but mainly AWS Cloud is the most popular cloud provider, with Microsoft and Google kind of growing, and after this is a huge gap. If you will see how the organization adopts serverless, you will see that many organizations try to use some kind of serverless stuff for different purposes, but especially in the AWS area, it's just very, very popular. A lot of serverless offerings that you just focus on the business logic. The same is also true for other cloud providers. If we will look into the Lambda, which is in the heart of AWS, this is the serverless option for writing business logic in the managed environment, then you see that the adoption grew as well. So this is, that was too quick. So this is really, the wrong button. So you see that the adoption increased, and we see a lot of companies doing some kind of serverless stuff. Probably adoption got stuck in this year. That has some reasons, but it's really a hot topic over there, I would say, the last 4 years. But if we will now look into the life of Java serverless developer on AWS, we will find following. So the managed Java 8 environment is supported still from the very early days, and Amazon provides something called Amazon Coretta. This is similar to the adopt OpenJDK. This is the open source Java 8 version, which is patched back. So all the security patches and so on are patched back. The Oracle version is out of support, so you need to pay for this, and this is still open source, and they guarantee that the support is currently until 2026. It doesn't mean that you should stick to Java 8 until so much, because Java 8 is kind of outdated, but nevertheless, the jump into other versions may be very difficult, so at least they provide support. They also provide support for Java 11 since 3 years, and currently there is Java version 17, but Lambda doesn't provide Java managed version 17 currently. So that was my hope after 1 year, nearly 1 year, that they will add this. It will happen probably even this year, but currently it's a bit gap. So if you would like to use managed runtime, it's currently Java 11. So Java is itself very fast and mature programming language, but if we will look at the serverless adoption of Java, especially on AWS, then you will see something like this. We will only focus on the first number. It's around 6%. So the people writing Lambda with Java as a programming language, there are only 6%, and most of them write Node.js and Python. And we will look into the statistic, why is that. So this was the report for the last year, and they say, yeah, with these features, provision concurrency and VPC improvements, things will change. Yeah, provision concurrency is there. We will also spend some words about this, but generally nothing changes. The same is kind of the statistic also from the last year, that from the other source, that you see Java adoption is kind of below 10%. And another statistic from another angle, percentage of organization using this programming language within Lambda, so within this managed environment, you see that's a bigger number, but it doesn't mean that this is for really hot applications. These are mainly for tooling and so on, but you see a huge gap still to Python and Node.js, and the gap will become even bigger if it's in kind of production application. So it's worth looking to the reasons. So why is that? Yeah, companies have a lot of savvy Java developers. Many of them embrace cloud, and serverless is a good fit for many kinds of applications. But then the people should learn Python, Node.js, and sometimes it's just not what you would like to see. So you would like to reuse your knowledge and so on. So these are two main challenges that we will go through. So the first is the cold start times, which are quite huge, and that means latencies in some cases. And also this is kind of bigger memory footprint, which is in the AWS serverless world means higher costs. Yeah, and these are two factors that may be kind of prohibiting, and we will look into them and how to deal with them. So as many don't have work with AWS and so on, I would just go a bit over the basics, so over the AWS Lambda. So this is kind of function as a service, yeah, where you write your business logic, and then you select the managed environment, so you don't manage any Tomcat and any Java, so you simply say, I would like to use Java 11 Corretto, give my function the name, and then kind of write the business logic. So on this side, you see what managed versions Lambda provides. So we only focus on Java, but there is also Net, Go, Ruby, Python, and also other stuff that we'll look into. And what you will also have to provide is the memory which your function will use. And this starts from 128 megabytes until 10 gigabytes within 46 megabyte steps. And what's important, everything's fine. What's important is that until 1.8 gigabyte of memory selected, so starting from this, you will get only the full core. So if you select less memory, you will only given the fraction of the CPU. So if you select half of the gigabyte, you will have roughly a quarter of CPU cycle. Yeah, and it will play a huge role. And if you select then 10 gigabytes, you will get a maximum of 6 cores. And of course, it only makes sense to give more memory than 2 gigabytes if you can just do something in parallel and use those cores. If it's single-threaded, then you simply will lose money. So the last parameter is how many timeout. So in case that you troubleshoot, so maximal is 15 minutes, but most functions, or if it's public-facing application, it's clear that 15 minutes timeout, just it's insane. Generally, you have to select something in the seconds area, just to provide feedback or deal with this asynchronously. So it's in case for debugging and not running out of the cost, because you will see the pricing that we will also pay for the duration. So 2 examples how we can write this function. In Java, there are much more possibilities, but these 2 are kind of common. So the first one, we implement request handler interface from AWS SDK package. He comes here, and then there is only one method, handle request with kind of request, and then it gives back the response. And with that, that's the business logic. So this conversion from Java, from JSON to object will be automatically. What you see here, we will have this context object passing here. It also comes from this SDK. We will also see what it gives us. And the second possibility is kind of SDK agnostic. You don't see any AWS code here. It's simply function interface from Java 8. So with the method apply, the same input and output, and there is no context there. So what's the difference? It's up to you. I like this context object that gives me logger injected, and I can log the stuff. I don't need to inject it anyway, and sometimes it helps with kind of debugging into the console, because I can call this get remaining time in millis where I want in the code. And this is kind of how many milliseconds are left until the timeout. And it may be very useful metric. It's not the best situation to debug, but sometimes it's easier just to write it down and then see where you spend time, because debugging in the cloud, it's just also another tricky point. So I personally prefer the first one, but generally you can use both of them. So now we will look into the AWS pricing model. It may be similar between other providers as far as I know. So in AWS, you have kind of 2 dimensions, how these lambdas are built with a business logic. The first one is request, and the second one is duration memory, I would say. So the first one is very easy. So you pay $20 per 1 million invocation of Lambda. It doesn't depend on the programming language. So it's number of invocations. So if we use Java or Python, doesn't matter, we will pay the same. It's your architecture which will drive this. The duration tier is much more interesting, where we pay for the gigabyte of second. So if we assign to the Lambda function 1 gigabyte of memory, and if it runs 1 second, we will pay this amount. It also depends on the hardware architecture. So x86 was there forever, and last year they also added ARM, so Graviton processor, so all the stuff that AWS developed, and they do it cheaper. So generally that means 1 second per 1 gigabyte. So in case if we select 1 gigabyte memory and the function runs only half of the second, we will pay the half of the amount given. So this kind of very trivial example, which cannot be always true, because no Lambda function can run with the same amount, so the take is the same amount of time. But if we will imagine we have 1 million requests, we have Lambda with the x86 processor architecture, we assign half of the gigabyte of memory, and each of these million invocation take 200 milliseconds. Then for the request here, we pay $20, and for the duration memory, we'll pay this amount. So this is kind of to understand how this pricing is working. Now we will come back to the challenges, and the first one is this so-called cold start. So probably it's very different if you use this function as a service. So people sometimes don't understand how this whole works, especially if this Lambda, this container, can only handle 1 invocation per time, and we will look into this. So how it works if we deploy and call the function for the first time. So first of all, we should deploy somewhere the code of this function. In AWS, it's just S3 storage. And if we call this for the first time, then the environment should download the code. So then the new execution environment will be started, and this is kind of I would say this is the kind of Java environment. Then the static initializer block of the function should run. So all the static code, all this class loading stuff should run. And only then the last step is to call the function body, this apply method or handle request method. It's then the last step. The first steps are called call start because it just doesn't execute the business logic, and the last one is the warm start where only the function runs. Well, business logic itself. So let's look into how the last three steps work. Especially, so this is the first step is to start the Firecracker VM. This is kind of container orchestration where this, from AWS itself, where the function is running. You can think of Kubernetes. That's the same, but AWS implemented their own stuff. But generally, some kind of container orchestrator who finds the environment there your function should run in the most efficient way and reuses it or something like this. Yeah, so then AWS Lambda starts the GVM. Then Java runtimes loads and initializes the handler class. And this is, now it becomes very interesting what AWS gives us. They give us, in this static initializer block, the full CPU access for 10 seconds for free for managed runtimes. It sounds very complicated, so I will break it down. Managed runtime is kind of Java 11 is managed runtime. We will also see there is custom runtime or Docker that you can also use. Then it's not for free. And full CPU cycle, remember, if you can assign the function quarter of the gigabyte memory, and then you have only quarter of the CPU for the main function, for the function body. But for the static initializer, AWS gives you always the full CPU, so you can speed up. That's the reason. You can speed up there, but only for 10 seconds, and it's for free. So you can think of what can I do in static initializer block, which is always a good practice to offload their stuff, but it gives you this possibility. And the last step is here, just Lambda calls the handler method with your business logic. So now, how it works. So first of all, this function as a service, as I told you, it's just not that how we use the container or normal infrastructure. The server can scale until it can handle the load, and then just another virtual machine starts. So this container with Firecracker VM can only execute one function, one container, one function in the time. So only if the function is executed, then the container will be kind of become free, and then you can reuse it for another one execution. That's kind of like data source stuff. Yeah. So you just cache this, and then you can pull the connection, reuse it, and bring it back. That's the same stuff. Only one invocation. So now it's about how this things works behind the scene. So for example, you deploy the function for the first time and use only one invocation of it. Then the container is not there. So you change the code, and then the code need to be just downloaded once again. And that's why then the call start happens. The first try, you didn't do this, then the first run is there. So it may happen that you try to execute two functions directly in parallel, and nothing is there is no container. Then you have both containers will have the call start. First of all, you need two in parallel, and two new in parallel needs to initialize something. If this container finished the work, then it comes kind of to the warm pool of containers. And if there is a free container, and you send the request, and this free container will be reused, and you will have only this last step, the warm execution, where the business logic runs. And that's kind of how it works all the time. So if there is a free container, then it will be reused. If there is no or not enough free container, the container needs to be started, and then you have this cold start. Maybe code download, but this GVM initialization step and static logic that needs to be done once again, and it costs time. So there is also one thing, even if the container is warm and is ready, AWS recycles it for the security reasons. They don't publish how often. People try to just figure out, so something like between 1 and 2 hours, the container will be recycled for the sake of patching the infrastructure and just all the security stuff and so on. So you don't have these warm containers for days or forever. So they will be recycled anyway in case. So you can run into this cold starts problem, depending on your architecture, kind of often. And we would like to see what does it mean to run this problem. Maybe that's not a huge problem. So this is very, very simple applications, which doesn't do anything besides kind of hello world. And then you see how much does this cold start take depending on the language, programming language. And then you see that the Java is in category nearly, it goes up to 1 second for the cold start without any logic. Yeah, so this cold start is kind of depending if it's completely asynchronously, it may be fine, it's not the problem. Or yeah, it's internal application, it's not the problem, but if you do something publicly, and then we will see it's just simply the very, very small application without any business logic. We don't write something like this. And you also see why JavaScript, Node.js, Python are quite more in use, because the cold start are nearly not there. So 0.2 seconds is just nothing. So the situation is that this below 1 second cold start is just very simple application and can go significantly up with the most complex scenarios. So the first Lambda I wrote without applying any optimizations, because I didn't know them for years ago, took me something between 20 and 30 seconds of cold start time. And you can think of if even 1% or 0.1% of the users have to wait between 20 and 30 seconds, you will lose them. Yeah, so it's not a good situation. And of course, if you're in AWS world, you're using other services, DynamoDB for NoSQL database, simple notification service, SQS, or simply, I would say, kind of HTTP call, it will significantly go up. And it depends also on other factors. For example, the whole artifact size. Yeah, bundle the dependencies of everything that you use. It's very difficult to understand graph, but what it says is for the small zip, depending on Java 8 or 11, you see that the call starts will be here, quite below. But if your artifact size with the all dependencies will increase, either with large zip or large jar, it doesn't matter, then it also increases the call start, because you have more initialization work, you need more, just all that stuff needs to be done, and then it increases also the cold start. We will see also how to apply best practices just to decrease that stuff, because it's just something between 10 and 20 seconds, it's not okay. So let's start with some basic stuff. So many people wrote this Lambda function several years ago, where AWS SDK 0 version was there, and stayed with this, and yeah, you need to upgrade to version 2.0, even if it breaks a lot, unfortunately, but it gives you also a lot more. So you will have lower footprint and more modular stuff there. It also allows you to configure HTTP client in case you need to communicate to outside of the world from Java, which may happen if you call PayPal, Stripe, something like this, then you need to communicate. And the situation is that in normal long-running application, what we use is something like Netty HTTP client or this Apache HTTP client, but they are more for the application. They rely heavily on caching and all that stuff. And with this serverless application where the functions are short-lived and the caching is just just uses the memory, it just uses time, it's not what you want. Yeah, it's just kind of, you would like just to do the things quickly and then and just not to over reuse, because the containers will be recycled. So this caching is not always the good stuff. So the AWS gives you the possibility to plug their own asynchronous HTTP client, and you see that the cold start is there. It's a bit better, or even much better than native stuff, than even default HTTP or URL client and so on. And it's very, very, very easy to initialize. So another stuff that gives you that's kind of logically with the SDK version 2.0, you can explicitly mention dependencies that you use. With the version 1.0, all AWS service dependencies will be bundled automatically. They release the services kind of now, there are more than 400, and probably your application only uses DynamoDB and doesn't need other 299. But they bundled it in the first version, and now in the 2.0, you can mention what you would like to use. It's obvious, but anyway, I don't know how they came to the idea to do that stuff in the previous version. And anyway, of course, if something has the scope test, like JUnit and so on, just declare this as test. Otherwise, it just will be bundled, and probably something will be initialized, and you will lose time as well. And then this cold start. So the second thing, now we are coming just to the fact that this static initializer blocks gives you this full CPU access, and now we have to think about how we can use this. So this is example of AWS service which we use in our Lambda. In the same way you can initialize all other services. So many people initialize this in the function itself, but this is something very perfectly suited to need to be initialized in the static initializer block. It takes time to initialize, and then if you receive there the full CPU, you can speed up. Of course, it's just kind of trade-off between doing things in the static initializer block and then having the cold start, or doing this in the function itself, and then adding each time to the execution time. But generally, it's quite preferable to do all this client initialization, everything that can be reused between invocation and the static initializer block. I think alone this call saved up to 5 seconds in the, for me then. So another thing is, if you deploy to AWS account, so your function, generally deploy this to some region that you use. We are using, for example, EU Central 1, this is Frankfurt. And sometimes we don't provide the region, and credential provider, and so on, because AWS can figure out what is the region. They know where you're deploying your function, of course, yeah. And also credential provider, they have kind of like filter chain, they have credential provider chain, they go from one invocation to another and try to figure out where your credential stored, but it takes time. And you know perfectly what is the region and where the credential provider of the stuff. So please do this, yeah, with programmatic call. It will save more than 1 second to AWS not to look up for this, but just derive this from this code as well. Another optimization which is heavily discussed is that the people using Java know that there are 2 levels of optimization, so client and server compilation. And with the server compilation or C2 compilation, this is kind of, yeah, this is just-in-time compiler, which like you are doing the first 10,000 invocation, they optimize everything in the end. So they look what the code can be thrown away, what paths are not reachable, and so on. But it takes by default up to 10,000 invocations. Situation is in the live environment, probably your Lambda function won't have so much invocation, then the container will be thrown away. So the question is, what's the value of this C2 optimization? Because it also takes the memory, it takes some thread and core, because just the process runs in parallel to a function and gathers all the data to each invocation. And the question is, should I do this? And by this optimization, you simply say tiered compilation, stop at level 1. So this is stop at here. You're kind of doing some kind of trade-off. With this, you can save up to 60% of the start time, because just no process is busy with this optimization. But for the execution itself, you may lose something, because this optimization may improve on the other end. It depends on the function, but generally, the C2, you may not benefit from this, depending on the situation. It's kind of wise to deactivate it, which is totally stupid idea in the server world. The Tomcat may run. If you don't use auto-scaling heavily and the application runs for weeks, then this optimization is quite useful. After 1 hour, you have reached this steady state. And this cool stuff, that's another world, but serverless is kind of different. So now, general advice, and it's kind of funny for the serverless world, the things are going quite different. Yeah? So we should avoid reflection, runtime, bytecode generation, generated proxies, dynamic class loading, because it takes then time in the initialization, but it also takes time and memory, and then it's just because of pricing, it costs you money. Situation is, of course, then the people using Spring or Juice then ask, that's in the core of these frameworks. Yeah. So how we can avoid this is just how it works. Yeah. So yeah, probably we will look into Micronaut, Quarkus, but dependency injection frameworks which are not reflection-based will kind of be better choice. Now we'll briefly look at the cost optimization technique, and then also look into the GraalVM. So the cost optimization, once again, request tier doesn't depend on the language, and the duration memory tier is just gigabyte per second. Now the question is, what will happen if I will double the memory. So I assigned half of the gigabyte memory, I would like just to assign gigabyte memory. So from the memory perspective, I will double the cost. But there is also the duration tier. And more memory means also by default, and that's interesting, I forgot to mention this, if I double the memory, AWS will double the CPU cycles automatically. So it's also interesting trade-off because not every application has this equal ratio of memory to CPU. It may be CPU bound, it may be RAM bound, it may be network bound, but that's generally how it works. We can only assign memory, and then if we double the memory, then the CPU cycles will be doubled automatically. And with doubling, for example, the memory, the CPU cycle will be doubled, which means that the execution time may speed up. Now it's interesting trade-off. I pay more for memory, but the execution may be only half of the seconds. And it just may equalize the cost, and I will be quicker. Yeah, so just then I will be finished. So the situation is how to test this. Yeah, so more memory, more expensive. So you can use this Lambda Power Tuning tool from AWS that's kind of open source. And what it does, it just use a step function, which is kind of workflow engine. You simply say, this is my function, and I would like to test it with different memory settings. And just give me the output, what is the best price duration performance. And this is what it gives you. For example, this is the result. So you see here the sweet spot. You see that if you give more memory, then it's not quicker anymore, but you pay more. So with this, you see with 1 gigabyte of memory, I'm kind of with the sweet spot with, I say, speed and price. My experience is that the most function should have between half of the gig of memory and gigabyte. More, it doesn't matter. You won't speed up, and with less, you will probably lose performance. This graph becomes that's more complex because this was only with x86 architecture. And, as I mentioned, you can use ARM architecture, and that gives you also kind of what architecture will be better for you also. Yeah? And then architecture and memory. And so this kind of very, very flexible. It's the open source tool, of course, it's just kind of in advance. You should simply run all your functions in this test mode and figure out what's the best stuff is without running it in production, of course. So AWS provides its own efficient tool. It calls, the name is Compute Optimizer. What this does, you firstly deploy your function with some memory, what you think will work, and then it runs for approximately 2 weeks, and then they give you a recommendation. So in this case, you see that we gave 1 gigabyte of memory, and with 900 megabytes, I will have kind of between 15 and 7% discount, and the performance will be quite comparable. So that's just trade-off how just to proceed. You can start with the first tool and then continue with the second just to adjust. And this tool is for free, and another one is kind of also open source. So generally, Java is very well optimized for long-running server application with high startup times and high memory utilization. But then this is kind of the serverless world is completely different. And that's why GraalVM enters the scene. It's also not the talk about GraalVM, and I'm only interested in on several aspects of this GraalVM, but generally it's just low footprint ahead of time mode for Java-based application, or possible ahead of time compilation, and so on. There is also interoperability of languages, which is kind of out of topic for here. What is also important, they give you, GraalVM also works also only with the long-term Java versions. So currently 11 and 17, so there is no GraalVM for 15, or at least I didn't find it. So what's interesting with this GraalVM is exactly this substrate VM. And this substrate VM gives you the possibility to use ahead of time compilation, which in turn is kind of the mode, then you have this closed world assumption. Then before, so in the compilation phase, everything that is reachable should be investigated. So all method fields and classes, and then everything will be compiled into the native image. So native image is native for Linux, native for Windows, or Linux, or native for Mac. And of course, the advantage of the native image, so there is no Java compilation between, so it starts quickly and it only has packaged everything that we need. So there are no dependencies that are no use and so on. And that's why we can even pre-initialize things there, which help with the reducing of the cold start. And also memory footprint is quite low because we are on the native memory side. So just this Java and so on. There is basic memory management, but at least it just doesn't occupy too much memory. So with the native image, there is a chance that we can reduce this cold start and memory assumption even by the order of magnitude, and we will also look at some statistic. So the problem, or general problem, is you saw that we can select Java 11 as a managed runtime, but we cannot select GraalVM as a managed runtime. So the question is how I can even use GraalVM within my stuff, and AWS provides the option to provide the custom runtime. Yeah, so just not one that is here selectable, but with a custom runtime. And this in turns work like this. This is only Linux. Yeah, and this runtime gives you the possibility to deploy native image. That's very important, but it should be Linux native image. So no support for Windows and also for Mac. And this is kind of the structure. So the bootstrap file is kind of the name of the native image. So you should compile with the GraalVM, simply spoken, and then the output should be this bootstrap native image. Then you should pack this into this function zip, and then select custom runtime as a managed runtime, and then AWS will run this for you. And with that, you can use this GraalVM. General GraalVM gives you the option. You can use just-in-time compiler because, yeah, GraalVM is not only for serverless microservices world, but has also advantages for normal Java application, server application. And of course, the trade-off is kind of different. So with the just-in-time standard stuff, it's optimized for peak throughput, reduced maximal latency, and so on. This is a long-running application. Ahead of time compilation, optimize for startup speed. Now, that's important for serverless sort, low memory footprint as well, and also small packaging. So all this stuff which contributes to the cost reduction and also performance increase in the serverless world. Of course, there are other costs because the compilation to the native image takes time. So every test that I do, it's nothing below 3 minutes. So this is kind of developer experience stuff. If you have this lots of Lambda functions in this microservices world, you need to do some small change. And then this compilation triggers, and it takes at least 3 seconds or something between 3 and 4 seconds. Then it may break some developer experience. Yeah, but everything has a trade-off. So now we will look into the statistics, so you can check out that the people have done this job. What you can see here. This is the comparison, so we only look into this blue stuff. This is pure Java, and the orange stuff is GraalVM native image. So there is also GraalVM without native image. The statistics is with GraalVM native image. And they simply check this serverless application, like HTTP API for the front door request, Lambda for the business logic, and DynamoDB for storing the data in the serverless world. So this is how it typically works. And what you see here, okay, many application doesn't start with Java with 128 megabytes. So it's not enough memory. But with a quarter of gigabyte, you see the cold starts, yeah? Just 6.5 seconds. So this is also very small application. I told you that it even probably optimized. And with the GraalVM, you are currently 715 milliseconds. And with the more memory, it becomes better also for Java, but anyway, you won't go below 2.5 seconds. And with the GraalVM native image, it's half of the second. And just you see it's comparable to Node.js and Python. So it's not a huge difference anymore, and this GraalVM shines. But anyway, many people use the frameworks for the sake of developer productivity, like Spring Boot and so on. And generally, the question is, yeah, you can use plain Java, but there are also, yeah, then there is a problem. There are also solutions. And so these two kind of Micronaut and Quarkus are both application or frameworks which come to the rescue and gives you kind of developer experience with annotations, with the whole ecosystem, with HTTP client and so on in different ways. But also Spring developer recognize that they need kind of to adopt Spring to support this native image, and that's why the Spring Native project was born. So all this stuff has common principles. It relies, if you use this for the serverless, with the possibility for native image, it relies as little reflection as possible, or even no reflection. All this runtime stuff is then avoided. So even annotations are all processed in the compile time, so it's just shifting, and that's why the building time is so great, and the common goals are increased developer productivities with that frameworks, maybe even further decrease the cold starts, because some frameworks can do further optimization that Java cannot do, because they sometimes know how to deal with this. Micronaut has this, for example, and so on. So we are running out of time. I will show you several steps. So how this all works. They are quite similar. So I wrote some sample applications and then run them with GraalVM native image with Micronaut, Quarkus, and Spring Native stuff. So the stuff is simple. You need GraalVM framework. You need GraalVM and native image. You need Maven or Gradle, and then we need some AWS services just to deploy CMS, for example, to define the infrastructure as code to deploy it in AWS environment. So that people didn't work with this. It's not bad, but generally the goal is build a Linux executable with GraalVM native image, and then just deploy this function, zip with this bootstrap then into AWS. So let's start with Quarkus. It's kind of Red Hat and IBM world. So the framework comes from there. And they say they are Kubernetes native. I personally don't understand what is Kubernetes native. If it works on AWS, then it probably not Kubernetes native completely. That's probably how our industry works with all this always overloaded terms. But anyway, this is very useful framework anyway. And this is kind of very simple application. You wrote this, and what's really cool with Quarkus, they support Spring annotations. So the Spring developer can reuse them, and they don't even need to rewrite the code. This REST controller is just Spring stuff, and then you see all this stuff that we know from Spring Web and so on, or Spring Boot application. There's request mapping and so on, and just we have here a bunch of get and puts methods. And the whole magic happens more or less in their POM XML or GraalVM, so in the compile time. So they support natively this native image goal, which will build GraalVM native image for you. Just you can have this zip assembly that they rename this into their function. So you saw here, just there is no dependency to AWS. Just it's simple Spring function even, yeah. And what you can do then, that the whole magic is these two dependencies. Quarkus, Amazon Lambda HTTP, they will create proxy to AWS world, and this is Quarkus Spring Web. This is the Spring annotation processor, which will convert the Spring annotations to the Quarkus one. Yeah, but you probably don't need to know this, and then you can run, and then it takes 3 minutes, and then you will have your image. This is same serverless application framework, how you define your function. So this is basically what I say. This is custom runtime the world provided. This function zipped was built in the previous step. I only say where to find the stuff. And this is the HTTP gateway, where this URL will be generated. So how I can call Lambda from outside of the world. I simply reference this function here. And if I do some local deploy and give this template, then AWS for the first run will generate kind of the API gateway address for me. And then I can call the method that I defined in this with the REST annotations, like pets5. So people probably know how this works, but generally the same stuff. Same deploy. For the first time, I will get this URL, and then I can call the methods. And it's very, very easy to use. They also support microprofile, and that's why also microprofile annotation. So you can use all that stuff. If you don't want to use Spring annotations, you can use this microprofile annotations. So I won't probably go there. That's generally the same. What's interesting, you have probably here, Quarkus native container, you have the choice to provide, you can use the GraalVM native image, or you can use the Docker. So within Docker, then everything within the container then the native image will be built, which I personally prefer because just with the Docker I have the right isolation. I don't rely on stuff installed on my own machine or on some CI/CD tool. So I say, okay, please use the Docker environment and build the native image from this environment. For the first time, it takes even more time because Docker has to pull everything and so on, but then you will stay with the same 3 or 4 minutes. So, yeah, we went through this. So AWS Lambda currently works by implementing request handler interface and Spring Web annotations. I cannot use Lambda with Quarkus, which implements Java 8 function interface, which works with the pure Lambda. It just shouldn't be this. I don't know if people would like to do that, that's okay, but the first two options are sufficient. You can use website like Spring Initializer, then you can simply define your dependencies, and then even POM XML will be generated, even SAM stuff will be generated, so very, very cool stuff. And you can use the CLI with the Quarkus create app, and so on. This is the level even above this, and even SAM templates will be generated for you. So check it out if you would like. I know a lot of people use the Quarkus even with the Azure and so on. So lots of possible things. So the Micronaut, the similar story, but the situation is Micronaut doesn't support any standard, and it comes more from Oracle AWS world. So if Azure supports one framework, then the AWS will support another. This is how this competition works. And I know that the people from AWS are sitting in the advisory board of Micronaut. The Micronaut founder is Graham Roche. Probably people know them from the Groovy world, so Groovy, Grails, and so on. He is the founder of the stuff, and now he's working for Oracle. So for me, it's a sign that the Oracle and AWS will support more Micronaut. But they go with their own approach. So the application looks similar. You see controller, post, get annotation. They're looking quite similar, but these are Micronaut only. So no micro profile, nothing. But generally, they try to be as lightweight as possible. Just don't rely on a lot of standards and so on. The same stuff also here. The whole magic happens with the POM XML. Here's the Micronaut AWS dependency. The proxy will be generated and so on. And also the same stuff as with Quarkus. They support also native image, GraalVM native image, pure Docker, but also Docker native image. So Docker native image means Docker container, and then the native image of this will be built. So you can choose, but for the serverless world, especially native image and Docker native are kind of a way to go. The same stuff. Yeah, you have this website where you can just like Spring Initializer generate stuff. Customer validators, no support for microprofile. They support Micronaut ahead of time compilation. Where they say that they're simply doing a lot of optimization, a lot more optimization in the compile time. Even that Java cannot recognize. They cover this, they describe what they are doing. That's a lot of caching, converting, optimization by loading, deduce. So all that stuff that normally will happen within runtime, they try just to detect and doing the stuff in the compile time. Of course, it then takes time. This is probably the most happy case with Micronaut described, that if you use the IoT, then the cold start is reduced by 85%, but or even here in the native world, drastically, but it's the most happiest case that it gives. So I would say that normal application will not have that much benefits from this IoT as described here, but so simply test if it gives you the opportunities to improve more. So Spring Boot framework, yeah, as I told you, so the Spring developers had probably the most difficult job because they had to rewrite probably a lot of stuff underneath to enable Spring Native world, and it will be probably enabled in the fall. So Spring Boot 3 and Spring Framework 6 will then support Spring Native project, and that's why the same stuff you can do simply, yeah, you can then write Spring application and then generate native image from this. Yeah, probably I will jump over. It's just a lot of logic which works the same. That's the same stuff. They support native image profile, and all these dependencies to AWS are also so the same. They all work kind of the same way. you write the pure business logic, and everything then in the POM XML will lead to the native image build and so on. The interesting stuff is that the Spring Native is currently the only framework which doesn't support Spring annotations. So that's quite interesting. So they only support request handler from AWS SDK as a way to write. Quarkus supports this, Micronaut supports this. Probably it will be added anyway, so you cannot reuse your Spring functions. You have to adopt this to this interface. Kind of funny, but yeah, maybe they will improve. So then kind of comparisons of these frameworks. So now what you see here is that this is the managed runtime with this framework. So we use pure Java. So this is the same application or similar API gateway, a bunch of lambdas. We are storing the results into the DynamoDB. And here we have the same application with GraalVM native image using this framework. So what we see, probably new. So this is P50, P99, and just you see pure Java without GraalVM, you have this cold starts. Yeah, these are the cold starts, and that's kind of what I also, that my experience. So the Quarkus is the best one here. Micronaut after this and the Spring Boot, yeah, they're quite new. So the cold start with the Spring Native with Spring Boot is kind of high. If you have native image, then you have kind of completely okay cold starts, I would say. So that's the same stuff. Quarkus is a bit quicker there with the cold start. Micronaut is just behind, and Spring Boot is a bit behind Micronaut. When I tested the stuff 1 year ago, the cold start of Spring GraalVM native was a bit more over 1 second. So they improved 50%. So they're kind of catching up. Huge community, it's not wondering that happens. So this kind of gives you, this GraalVM gives you these possibilities to go with a cold start within, I would say, acceptable areas. There is one way more. You can use Lambda container image support, so you can deploy also pure Docker applications if you would like, just no GraalVM, kind of, yeah, so you don't have these native images, but you can use Docker. It's only just to give you what it gives you. With GraalVM, you have only long-term versions. If you use Docker, you can rely on the recent version. So if you're in the situation that 2.5 years and there's only managed runtime, which is Java 17, and then you can use then Java 23, which will speed you up, and your application is not sensitive for cold starts, then you can simply say, I would like to use more modern stuff. And with that, what the modern stuff can give you, this granularity, which is not possible with GraalVM, you can use other stuff like JDepth, which analyzes what dependencies do you have in your application to the JDK. And with JLink, you can build the smaller JDK. Yeah, and you can also rely on the feature of class data sharing, which shares some data between invocations. So it's not, you will not achieve the numbers of GraalVM native image, but with this stuff, you may improve, and if it's not then sensible, you are simply allowed to use the recent Java version, and that may improve your productivity on the other side. So another trade-off. So probably the conclusion, GraalVM and frameworks were really powerful with a lot of potential. Native image of GraalVM improves cold starts and memory footprint significantly, but GraalVM is not without challenges. So AWS Lambda custom runtime requires Linux as executable, so that the people working with Windows and Mac needs to just to build and deploy this. Yeah, so they just should use the foreign machines. Building custom runtime requires some additional effort, so you need to manage the CI pipelines by yourself. If you have a lot of functions and each takes 3 to 4 minutes to build, and it requires 6 GB memory to build the native image, and then you have to scale this. You need the infrastructure to do it yourself. Otherwise, your developer experience may be even worse. Yeah, that's another factor. So build time is a factor. And as I told you, you pay for initializing time only for Java 8, so managed runtimes. So the Docker runtime and custom runtime, you also pay in this init phase for 10 seconds. It's not a huge amount that you will pay, but good to know. So personal recommendation, that's probably the last slide, highly opinionated. So start by default with something simple, plain Java. So don't use this AUT and GraalVM and so on. You can try the frameworks without native image mode. It works as well. It gives you more productivity. And look what's most important for you. So if you don't want to miss the years of innovation, use the Java version, the latest Java version, then use the Docker container. Yeah, if you don't have this sensible application, if you need constantly low response times for a known period of time, so you have at 9 p.m. newsletters, yeah, then you know I need to scale between 9 and 9:15 because millions of emails will be sent and people simultaneously click on these links. Then you can use provision concurrency. We didn't talk about this. You simply can say, please provision 500 warm containers from 9 until 9 o'clock 15. So like warm provisioning. You will pay for them even if you don't use them. That's the trade-off. If you don't know how many, you will probably over-provision and overpay. That's the trade-off. But if you know exactly the time, which is probably not very often, then you can use this. Of course, if your function needs constant low response time and low cost is a requirement, then GraalVM native image will be the option to go in the only one currently I see. Within Java world, probably people interested in Java know this acronym CRAC, which is quite new. And the CREO project where you can save the state of the application and reuse this is kind of new, but there is nothing in the AWS world to support this. But if you know Simon Rita and all that stuff and Azul, so look into the talks, they are working 1 year for this to improve this from kind of with another trade-offs. But cloud provider needs to support it, otherwise, yeah. So the usage of the frameworks, Micronaut and so on, they may improve your productivity, but there are some reports that if you use these frameworks, it may add time also, sometimes even to cold starts, not for Micronaut, so Quarkus was kind of mentioned, and may also increase build time because other dependencies and so on. So I have here several links that you can try the stuff out, even from the official sources. And with that, I know it was quite a lot, probably for Sunday morning, but at least I hope it was entertaining. So thank you very much. So what questions do you have? We have several minutes.
Hi, thank you. On one of the slides, the GraalVM editions were shown, like a community edition and enterprise edition. So can you briefly explain which stuff is limited to commercial editions, and so what limitations do you have if you don't want to pay?
Yeah, there is a community and enterprise edition. With enterprise edition, you will have a bit more performance boost. Yeah, they need to sell this, and as far as I know, Oracle gives you the GraalVM Enterprise Edition for free in their Oracle Cloud. I don't know people using it, but maybe there are. That's it. So a bit more performance optimization. There's so some stuff which is really sophisticated. So this is kind of pricing model. Yeah, and I only used the community edition. It was enough for me to see the boost, but probably you can win another 10% if you pay for that.